All right, so this is basically our OSM reference system, which aims to help out with ensuring that the human component of the driver monitoring spot testing for type approval is actually done correctly. So reducing the subjective human factor noise into the calculation. It utilizes the SmartEye Pro tracking system. So it's a multi-camera research grade system, and it's these 3 cameras over here. And that gives you a tracking foundation for the actual test participant. We're also utilizing two web cameras. So one here that looks at me, the test participant or the respondent. And then we have one behind my shoulder here, which looks at the infotainment system, or the cluster rather, in order to record the vehicle response. So both audio and video is recorded there. So the tracking happens here in SmartEye Pro. We also have iMotions, which is the data recording platform. And here we collect all of the tracking data accompanied with the video and audio from these web cameras, and also some metadata from the third component, which is the reference tool. And the reference tool gives you the ability to get all of the scenarios from a certain type of test specification. So in this case, we will use euro-NCAP. So first we need to enroll ourselves to be able to create a study in iMotions. So we'll name this demo and put in my credentials like so. And then we'll load a CSV file. And this is how we actually enable you to load the test scenarios. So this is configurable to basically every scenario you could want, as long as the analysis is supported in the backend. So you load the file and you get greeted by all of the test scenarios for the distraction in euro-NCAP currently. So this consists of the type of distraction. So you have long distraction, which is a continuous glance away from the road. And then you have short distraction, which is an alternating glance away from the road to a certain object. So the object is referred to in the zone here. And then we have behavior is how you move your head during these scenarios. So owl means that you're turning your head towards the target, and lizard means that you're keeping your head still and just moving your eyes. We have some leeway there because you can't assume that a person can be perfectly still, but the intent is to keep as still as possible. Then you have glance duration, which is the duration of one individual glance. For long distraction, it's only one glance. So then the total duration of the scenario is the same. But for short distraction, you have shorter glance duration for each glance, and a total duration that is longer because there's multiple glances. We also have a velocity column, which basically tells you which velocity span do you need to be within to have a valid or expect a valid vehicle response. So we have a GPS connected to the PC working this that gives us speed data that can relay that information back to the driver while you're doing the test. So let's select a couple of scenarios. So we'll do the long distraction driver side mirror owl, and then we'll do the short distraction rear view mirror owl here. So first we will go through the calibration.
Coordinate system calibration. Look straight ahead with your nose pointing straight forward. Press continue when you are ready to calibrate.
So first we calibrate the basically the floor, or what's up and down in our cabin, just by looking forward.
Calibration successful.
There we go. And then we'll calibrate the objects.
To calibrate an object, look at the center of it with the instructed behavior type. Then press calibrate.
Okay, so we always have road because that's sort of the foundational object you start with and end with in each scenario. So you need to refer to that always. So let's look forward and do the road, like so. Then we do driver side mirror owl. So I'll turn my head. And then we'll do the rear view mirror owl. There we go.
Calibration done.
Now if we look in SmartEye Pro, we actually get a 3D representation of our objects here. So these are what we are using to inferring the correctness of the behavior made. So the gaze vector is intersecting with these objects, and that's how we get the data from if you're doing something correctly or not. If we continue, we'll get prompted to start a recording or start a study in iMotions. So we'll create one, and SmartEye Pro is nicely integrated in this. So it's just a couple of clicks, and we need to name this like we named it in the reference tool, and now we're ready to go. So now we're gonna get some introduction on how to do these tests.
Each scenario will start with an explanation of the expected behavior. After you are done performing the behavior, you will be notified if the scenario was performed correctly or not. You will then be able to either redo the scenario again, or continue with the next one. When you are done, the program will automatically return to the landing page, but if you wish to stop the test before that, just press the Stop Test button. Good luck.
Alright, so now we will get an explanation of the first scenario.
Look straight ahead. At the signal, turn your head and look at the driver's side mirror. When you hear the next signal, look back straight ahead.
Okay, let's run this. And there I got a confirmation that everything was done according to specification, so we can move on to the next one.
Look straight ahead. At the signal, turn your head and look at the rear view mirror. When you hear the next signal, look back straight ahead. Continue to alternate at every signal until the test is done.
Okay, let's go. And that one was successful as well. And now we've finished our tests. So now we can go back to iMotions, and here we have a recording of our tests. So if we go into this, you will see that we have the camera recordings, both for me as a respondent and the vehicle response, and also a view of the 3D coordinate system with the tracking data. So if you play here, you will see that the gaze moves around. But most importantly, we have access to all of the tracking signals from SmartEye Pro, as well as a few data points from the reference tool. So we have test number and sequence status, and also we're going to use the object intersection. So the test number basically says which scenario in the CSV file you're currently testing. The sequence status goes up to running and then pass, or running and fail, and in that way you can infer if the scenario was successfully acted out or done by the participant itself. And then we have the object intersection, which basically states where the behavior actually started. And now it's as easy as going forward to where the vehicle response occurred, creating a marker. So we'll call this vehicle response, like so, and adding it. And we'll do the same for this one, and we can say that the vehicle response came here, and then we'll just add an event. And after this, it's as easy as exporting all of this data, crunching it through a Python script, and getting a finished test protocol, really. So it looks for which scenario it is, so it knows the parameters or the specifications that it needs to adhere to. It also looks at if the behavior was successfully done, and then it looks for the time from the actual start of the behavior to the displayed warning. This makes it a lot quicker than all existing solutions, and it's quite neat. Cool.
Thank you.
Thank you.
Spot on.